The topic of this video is graphing transformation techniques, vertical and horizontal, stretching and shrinking. Let's look at a problem. All right, here's our problem. Graph the function f of x equals 5 times the absolute value of x. So the first thing you want to do when solving a problem of this type is recognize that this is very similar to one of our library functions, one of our basic functions, the absolute value function. And at this point in our video series, you should be able to quickly, from memory, create the table of x and y points that are associated with the absolute value function. You should be able to create that just as quickly as I did. Now, if we think about the graph of the absolute value function, and I'm just sort of going to draw a rough sketch here. It looks like this. It is a V-shaped graph. So our job is to take what we know about the absolute value function and then apply it to this new function. And the first thing we have to ask ourselves is, what changed? How is this equation different from this equation? This is the before, this is the after. Well, what changed is the 5. So here's what you need to be thinking. Here's what you need to ask yourself. First of all, where did the change happen? Was it inside close to x or outside far from x? And the answer is it's outside far from x. So that makes this a vertical transformation. The 5 is outside far from x. So that makes this a vertical transformation. The next thing you want to ask yourself is, what's different here when you compare these? Sure, the 5 is different, but what's it doing? Is it being added? Is it being subtracted? Is it being multiplied or divided? And the answer is it's being multiplied. So when your change is multiplication, that is indicative of either a stretch or a shrink. And the number, the value of the number, will tell you which one it is. Okay, so now we're ready to put all of this together. Here we go. We know that we're dealing with a vertical stretch or shrink. Vertical stretches and shrinks they behave exactly the way you would expect they would. Greater than 1 is a stretch, less than 1 but still positive is a shrink. And so with that in mind, 5 is a number that's greater than 1, so we are dealing with a stretch, a vertical stretch. So how do we get a new set of coordinates? For a vertical stretch, all of the y coordinates get multiplied by a. Y's multiplied by a, which a in this particular problem is 5. So I'm going to make my table of points here. The x's are going to be exactly the same. No change on the x's, because this is a vertical transformation, only the y's change. And how the y's change is they all get multiplied by 5. So 2 times 5 is 10, 1 times 5 is 5, 0 times 5 is 0, and so on down the chart. So now I can create my new graph using my new points. So I've got to go all the way up to the tippy top here with 10. So if that's 10, then that would be 5, and then 4, 3, 2, 1, 9, 8, 7, 6. This would be 1 and 2, -1 and -2. And now I can plot the points of the graph of the equation that was given to me. So -2, 10 would be here. -1, 5 would be here. 0, 0, the origin. 1, 5 would be here. 2, 10 would be here. Notice that this is the same shape as absolute value. It's just that all of the points have moved up away from the x-axis. It's still a pair of rays, and for that reason we must use a straight edge. Lines, line segments, and rays must be drawn using a straight edge. So I get out my straight edge and I graph my rays through these points, and this helps me create my final graph, my final picture. This shown in blue is the graph of the function f of x equals 5 times the absolute value of x. I think the only thing maybe that I'm missing here is this right here. We'll label that with an X, and establish the scale on the x-axis. And there we go. We are done with this problem.